Hello and welcome to Watch This Space with Rivada Networks. I'm Brian Carney and my guest on this episode is Tom Kunath of Cisco. Tom, welcome to the show.
Hey, thank you, Brian. Great to meet you.
Really appreciate you coming on. Tom is a solutions architect at Cisco, and he's been working with the Rivada team on how to coordinate and integrate networking between, I guess, I don't know, you tell me, Tom, but between terrestrial and satellite networks like the Outernet, is that fair to say?
That's fair to say, yeah. And basically, everything that touches private networking, enterprise networking, whether that be in the sky or with terrestrial networks like ground stations and MPLS and carrier Ethernet, all of that, tying all that together with Cisco technologies is what I'm aiming for.
Okay, and so as I understand it, Cisco and Rivada have co-authored a white paper on how the internet fits in with the broader kind of corporate
Yeah.
networking, carrier Ethernet ecosystem, and how that all works. Is that correct?
That's correct. Yeah. I mean, the white paper is really set out to achieve a couple different goals. One is to kind of call out how Rivada is a little bit different from the other satellite internet providers that we've been working with and been hearing a lot about in the past couple of years. And then two, really kind of brainstorm some use cases, some potential use cases that we really see as being viable once Rivada is on the market. Knowing what we know from the industries that we work with today and enterprise, service provider, and even like the IoT space, we attempted to kind of talk about things we know we could do, and then really start to think about things that potentially we're unlocking with Rivada's unique approach to satellite.
So tell me about that a little bit. You said, the part of the point was to think about how the Outernet is different from
Right.
other satellite service offerings, and
Mhm.
obviously that's something that we talk about a lot. But from Cisco's perspective, or from your perspective, what did you see that caught your eye here?
Yeah. So, I mean, I guess, when anybody gets, their first taste of satellite, that's the whole whiz bang of, being in space and, being able to, offer up access anywhere in the world, they immediately get taken by that. And then once you kind of dive into some of the satellite internet providers, essentially to Cisco, it's just like a modem that connects to an Ethernet port. And what we found was that, like any other internet service provider, the degree of quality is best effort, right? So you're
Right.
kind of forced to deploy different conditioning features, QoS, things of that nature to kind of accommodate for a less than perfect experience, right? So that you can raise the customer experience. And so um, before Rivada, I worked with some other satellite providers in the lab, and essentially focused on that. How could we raise the customer experience on this satellite internet provider to be kind of equivalent of what you would see on a broadband internet, right? And what caught my eye with Rivada was essentially, this concept of MPLS in the sky. I've worked with MPLS providers as a customer supporting the internal MPLS carriers, to doing designs, to working in Knox for over 20 years, and so very familiar with that concept and the idea of gatewayless and having pole-to-pole coverage without ever having to touch a ground station, data sovereignty. That all kind of ring true to me, and it also echoes a lot of the comments I hear from my customers. Being able to have a private network, not just an overlay network on top of a best effort internet. That to me is what
Right.
makes Rivada stand out from my other experiences.
Okay, let me just back you up a little bit. NOC is Network Operations Center,
Right,
um,
right,
and MPLS is multi-packet label switching, but right, or something like that. But
right.
what
Multi-protocol
is
labels.
MPLS to a layman? Or what is the
Um, it's
significance of that?
it's essentially an IP network that can do fast switching, and it can take into consideration other factors than just the shortest path through a network. So it enables traffic engineering, let's say I have this real-time voice traffic. I want it to take the most low latency path through the network. MPLS can enable that.
Okay.
Essentially, there's applications such as that, and basically it allows to switch IP packets at like service provider scale due to the silicon in the MPLS switches. From the perspective of a customer, it's a private network that can handle all my routing. So I just essentially connect to it, and then they can route the traffic to my destinations. That's a layer 3 MPLS provider offering. Then there's a layer 2 provider offering that just essentially makes the network appear as if it's just on a single Ethernet. So I can talk to different locations as if they're directly connected. And that gives me a bit more flexibility to deploy my own routing protocols, deploy my own quality of service. I'm not dependent on the MPLS provider to do all that. So those are kind of the two different flavors of MPLS. And from what I understand, Rivada is going to look very much like a layer 2 MPLS service provider.
Right. I understand that it's the goal as well. But I cut you off when you were saying nice things about Rivada. So you mentioned that one of the things that caught your eye was the difference between having a kind of a best effort, essentially what I think of as, your ISP at home, right? They say up to 400 megabits per second or whatever. And, you might see that, or you might see 100 or 50 if you actually run a speed test. And, that's what best effort is, right? It's kind of the best case. That's the speeds you get, but there's no real guarantee. And there's, you may have contention on the network, and it's certainly not provisioned to, um, you know, to guarantee a specific level of service. You're basically paying for how hard they'll try to get close to that target number, and your numbers might be close to that, they might not. And certainly my understanding is other satellite providers are also in that same position of the up to, right, the best effort kind of thing. And for corporate networking, that's one thing if you're streaming movies and you get throttled or something. But for certain corporate networking applications and use cases, that can be a serious problem, right? And or at least,
Mm-hmm.
People are doing enterprise networking. They're often buying service. They're not, and they're looking for something better than best effort, right? Either uncontested or sort of a committed information rate, something that says, okay, I've got this pipe, and whenever I go to use it, I'm going to get the speeds that I expect and that I'm paying for. Is that fair to say?
Yeah, that's true. I mean, the satellite providers I've looked at so far, when they're good, they're good. I get surprisingly fast download speeds, not so much impressive upload speeds all the time. But as you say, the experience can be inconsistent. It can be inconsistent due to the weather. It can be consistent depending on where I'm going on the internet. If am I trying to build a tunnel over a satellite provider to another terrestrial location, branch office, or a data center on my network across the country? What's kind of hidden is all of the intermediate terrestrial hops that might happen during that time. And anyone that has worked in networking knows that that's where you usually find your problems. At the internet exchange points between providers. Those are typically found to be congested, and there's a lot of new kind of paradigm shifts to kind of eliminate that whole concept of having to go through multiple internet providers within networking. We have this thing called middle mile optimization now, where instead of going to ISPA that has a pairing arrangement with ISP B and C with maybe no SLAs, now we bring it right into a cloud service provider that can now carry us all the way through to the end with an SLA. So as I said, my experience was good, but it was quite inconsistent. And what I found was, not just me, but my customers came to me and said, "Hey, Tom, I've noticed that when I run a speed test, things look great. But when I try to actually use some real business applications, the performance goes down to about 25% of what I expect. And what I found through lab testing myself was that when you use like business applications, you're typically using applications on your computer that use the TCP protocol. That's the
Okay.
transfer. Okay, so TCP has built into it mechanisms to slow down the transmission rate if it thinks that there's congestion in the network. So if you're
Okay.
in a branch office and you got a lot of people working, and then all of a sudden that bandwidth is under provision for whatever reason, TCP tries to kind of help that problem by slowing down your transmission rate. And
Okay.
so what I found was that it was almost like a false positive. And where there wasn't actually congestion in the satellite network, what there was packet loss. And
Okay.
packet loss can wreak havoc on a network, right? Particularly when it's running TCP/IP. Packet loss, what it will do is interfere with this two-way kind of communications between a TCP client, like a computer, and a server. Essentially, the way it works is I send you traffic and you acknowledge you got it. And until I get
Got
that
it.
acknowledgement, I don't send you more. And if I
Okay.
lose the acknowledgement, I say, wait a minute, there must be congestion in the network. I need to slow down my rate by 50%. And then I'll slowly ramp it up because we're thinking that late acknowledgement was due to congestion, when what we found with some of our satellite testing, it was due to packets being dropped. And
Okay.
whether that was being dropped during the satellite handoff or in the ground station or the backhaul network, it was kind of hard to be determined. But my experience was that it was somewhat inconsistent, and I expect that it was due to backhaul networks just being maybe over provisioned, demand, surging demand over subscribing certain backhaul systems. And so, that's what I think you get with best effort internet, right? And
Right.
so, luckily at Cisco, we have a lot of innovations and a lot of features that can, condition that. So I was able to kind of showcase, features like TCP optimization and
Okay.
application aware routing and things that, essentially will kind of hide that loss to the end user and raise that throughput. Now, from what I understand with the Rivada, not touching any internet ground stations, we shouldn't see that level of packet loss. And so, and also there's going to be symmetrical bandwidth, meaning we'll be able to send at the same rate as received, which is very important for a lot of use cases, particularly file transfer, service provider use cases. I mean, that's going to be very eye-opening, and it will unlock a lot of use cases.
Right, because the classic kind of ISP use case, again, domestic broadband, whatever, is you're pulling down a lot of streaming video or whatever, and you're not sending that much back up. And so networks that are optimized for that sort of use case um, tend not to have big upload
Right.
capacity because
Right.
it's not needed. I forget, one of the ISPs in the US had those cheeky ads about half fast internet, half fast, but if you said it fast, it sounded racier. Um, it was a fiber optic network, and they were trying to emphasize that their competitors were only fast coming down, but not going up, which
Right.
was clever. But the fact is, at home, we pull a lot more down than we send up. At least most of us do, and
Right.
so it's kind of fine for the right use cases. But as you said, for certain kinds of customers and certain kinds of products, you may need symmetrical or you may need reverse asymmetrical for whatever reason. You may be sending a lot. I think about um, oil and gas. If you've got a remote drilling rig or something, you may be sending a lot more data back to the
Absolutely.
home office than you're
Hmm.
pulling into the rig, and so you
Hmm.
may
Hmm.
need reverse asymmetric connections to handle that load, or not want to pay a ton for an, a downlink that you're not using as much
Right.
as the uplink.
Right.
Um,
Yeah, it's a good point, and that is actually one of the use cases I showcase in the
okay.
white paper is an oil and gas deployment built based on a real customer deployment that I helped with. And yeah, so essentially, all these sensors, that are measuring the quality of the oil and measuring, when it's produced, needing to be able to send that back because, that all has significance on the market, right? And, that does require a decent amount of transmit bandwidth, of upload bandwidth. And what we found was that we had to, in some cases, aggregate multiple terminals to allow that to happen,
Oh, wow.
which on the surface it sounds easy, but when you dig into some of the technical challenges, it's not quite as easy to do to do it in the right way.
Right. Yeah, that's very interesting. Are there are there other use cases in the white paper that you want to call out while we're on that
Yeah,
subject?
absolutely. I mean, the first one that I talk about is a global enterprise. Okay, so I talk about a global financial enterprise. But if you look at the design of a global financial enterprise, it looks very much like a global healthcare corporation might look like, as well as a global retailer. Essentially,
From a data transmission perspective.
yeah, and from a network architecture standpoint,
Right.
right?
Right.
So when you think about these regional networks where you have like a presence in the U.S. and maybe a presence in EMEA and APJ, essentially, those are all going to be kind of autonomously run networks. For 20 years, Cisco has talked about this architectural approach that really still gets followed, where you have a discrete core, distribution, and access portion of the network. And so let's start with access. Access is just, essentially us on our computers, gaining access to the network with whatever type of transport we have. Okay, it might be a
Right.
internet connection like we have now. If I'm in a corporate office, it might be an MPLS. It could be a 5G, or it could be satellite, right? And essentially, there's things that you do in the access layer to authenticate users to make sure they're allowed to be on it. They're put into the right VLANs and virtual private networks, and then they all get aggregated up to what's known as the distribution layer. And the distribution layer is where you have large routers that aggregate multiple connections. They enforce security through access control lists, through firewalls. They do quality of service, they do traffic shaping, and then they hand it off to a core layer, which essentially connects the different regions globally. So the distribution layer is usually in a data center or a co-location facility. Again, lots of access information coming in. If it's a regional network, maybe the majority of that network transfer, it just remains within that region. But then there's always going to be the need for interregional connectivity, particularly when you have the headquarters of a company in one of those regions. There's going to be applications that sit in that data center that need to be available globally. And so the way that that's done is through this core layer. Okay. And the core layer is very key. And, where the distribution layer is about enforcement, quality of service, conditioning, fairness, and all that. The core layer is just about speed and availability. All right. Okay. So the core layer always needs to be up. High availability is crucial. And so when you look at a global financial or a global healthcare organization, they will typically not underspend on the core layer. It's not uncommon to have MPLS, a global MPLS provider, providing that transport. And in many cases, there'll be a redundant MPLS provider that sit there because the cost of downtime is a lot more than the cost of procuring and paying for a service contract from another core provider. Right. So immediately I can see Rivada playing a role in the core layer because it's a global layer 2 provider that can be brought up immediately, either as the primary core or as a redundant core. This attributes we talked about with symmetrical bandwidth, high bandwidth. We know that we've got high availability. When we think about MPLS, transatlantic type of terrestrial, I guess, undersea cables. We know that they're prone to sabotage. We've had some actual outages
Yep.
not too long ago, right? Of those, because the cables are in the ocean, they're easily can be tampered with. So I can see a lot of global financials finding this idea of this now layer 2 carrier Ethernet in the sky, that in theory can't be tampered with, is being attractive. And I could see many of them probably putting their toes in the water slowly. Okay, let's bring in our Rivada as our B network, right? We have an A and a B,
Right.
not that one's preferred over the other. It's just that they're usually kept separate. Like, you don't interconnect those, because if there's a problem with one, a routing loop, you don't want that to poison the other. You want them
Right.
to be
Right.
essentially separate, and it's available anywhere. So connecting into that core, should be easy no matter where you are in the world. So I see that as being some low hanging fruit, once Rivada is available, is in this core, but also in the access and distribution layer. When we think about how we're using satellite today, well, it's typically last mile type connectivity for
Right.
far flung places where maybe they don't have terrestrial options. Well, now maybe we do that even where we do have terrestrial, because the performance is as good or better, right? So being able to connect, banking branches, remote traders from home through a satellite connection, and give the same experience they could get with an MPLS terrestrial, that'll be something that'll be interesting as well.
Sure. And as you said, by going up and staying up until you reach your endpoint, you're avoiding, possible peering congestion and local loop issues, and in some ways maybe even simplifying some of your security and networking setup,
Very much
because
so. Yeah. Yeah, very much so. I mean, that, to bring up a core on MPLS, typically, uh, people can peer with the service provider. So now that means every touch point you have a BGP peering. Now there's BGP policy that has to be kept up with. With Cisco SD-WAN, we can do it a little bit easier. We can bring up SD-WAN tunnels on top to allow for traffic engineering. But it's always been not trivial to build a core network, that it needs to be highly available. It needs to, if a link breaks, it needs to reconverge fast.
right.
Now that we have this layer 2 network in the sky, we can pull out every tool that we have and not be dependent on a layer 3 service provider, and how long it might take them to detect a problem and respond to it, and things like that, right? We can essentially build an overlay core network on top of this layer 2. If we need to secure it with something like IPsec tunnels, we can do that. We may find that the financial organizations just treat it like they would any other private network like MPLS, where it's not mandated that they encrypt with IPsec, because it's private and you have your own virtual private network. But that'll all remain to be seen.
Right.
But what I do think is that it'll be, simpler.
So Tom, you said that, one of the advantages here is simplifying things. Are there cases in which this makes possible something that maybe isn't possible today, or kind of innovative use cases? So instead of just making existing things either better or simpler or more resilient,
Yeah.
allowing us to do something that we can't do now.
Yeah, actually, there is. And actually, there's two use cases I can think of. One is related to the global financial. Now that we have this layer 2 carrier Ethernet available globally, we can start to think about use cases that leverage IP multicast. IP multicast is a bit different from our normal client server applications, in the sense that it's almost like a broadcast network, but you only
Okay.
broadcast to people that are interested. So think about a market data stream where you are bringing out the market figures and they're being broadcast on a ticker. That's typically
Right.
done through IP multicast. And the reason it is that there's regulations that say that there has to be a degree of fairness. I can't send trader A the market feed before trader B, because now they can use
Right.
high frequency trading. And so traditionally, this multicast was kept locally within regions, just because it's difficult to do in a global sense. So
Right.
now I can see cases where there's global financials that can distribute this market data over multicast to consumers and traders and brokerage houses over this layer two multicast because it's so easy to do, right? So that's
Mm,
one. And the second one is a kind of a complete shift into the IoT or Internet of Things space. And so think now about a cargo ship that's out in the ocean that is transporting goods. And as we know, there's still places in the world where there's piracy, right?
yeah.
There's Somalia, there's Singapore, and these cargo ships are key targets because they're carrying high payloads. They've got a small crew of unarmed people that they
Right.
can easily overpower and capture, and so that's just a real problem. And now again, like any other sophisticated maritime, kind of ship, there's a lot of these command and control systems that run, the navigation, that run, the steering, and all those things are done at like a layer two level.
Okay.
These are older systems that they call IAX systems that are I forget the acronym right now, but it's essentially not even TCP/IP. It's very old technology that's tried and true, but it's designed to be real time. Okay, and
Okay.
so now we can think about unlocking these cases where we can have tele-remote operations of these cargo ships, so that we can, when we get to a dangerous part of the world, fly the crew, fly the captain off, and now remotely steer and control these cargo ships during, through these dangerous ports and portions of the world. And that's possible because
Wow.
now we will be able to essentially tie into the cargo ships at a layer two level and
Right.
be able
Right.
to potentially, remotely control with these non-IP protocols from a central safe location until we get to a port where we then would fly the crew back in and they would land the ship. So those are a couple of interesting use cases that warrant further investigation once we have Rivada ready.
Yeah. Super interesting. I like the idea of protecting the ship in part by taking away the hostages, right? I mean, it's
Yeah,
one of the points of leverage that the pirates have is
right,
the life and welfare of the crew that leads to, you know, concessions and so on. So if you take away that, you take away, you know, they can't haul every container off a ship, right?
right.
But they can hold the crew hostage and make demands. So that's really interesting, Tom. I think that'll wrap it for today. I'd love to have you back on and talk further. It sounds like there's a lot for Rivada and Cisco to talk about, and a lot that we could
Agree.
we could think about. And as we move through this process, I hope that we'll find more ways to collaborate as companies. And as I said, I'd love to have you back on the show at some point. So
I'd love to
thanks
join.
for
I
coming and thanks for the white paper.
appreciate it, Brian. Take
All
care.
right. Thanks. Thank you, everyone. This has been Watch This Space with Rivada Networks. Stay tuned.